Okay, so obviously this is not ideal to teach this way, but just kind of make the best of a situation here. So the first lesson is really just a review of Algebra 1. So it's not too bad. I'll try to go through this one quickly here. It's equations of lines. So if you remember last year, we call any straight line a linear equation. And it can be written in the form y equals mx plus b. And if you remember from last year, the m is our slope of the line, and the b is the y-intercept. Okay, so we'll take a look at two equations here. We'll graph both of these, and then we'll kind of move on from there. Okay, so y equals 2x minus 7. The slope here would be the 2. And the y-intercept would be the negative 7. Okay, let's go ahead and graph this. I always like to graph the y-intercept first. That's where it crosses the y-axis. So in the equation y equals 2x minus 7, the first point would be at 0, negative 7. 2, 3, 4, 5, 6, 7. Now the slope is 2, so we could go up 2 over 1, up 2 over 1, up 2 over 1, and keep following this pattern. Once we have enough points, we could go ahead and connect. I'll do that a little better. Okay. And I'll put arrows at the end. And let's label it. Okay, our second one, I'll do it in a different color here. All right. So the slope is negative 2/3, and the y-intercept is 3. Once again, I'm going to go ahead and plot the y-intercept first. So that's right here. And my slope is negative 2/3, so I'll go down 2, and to the right 3. 1, 2, 3. Down 2, right 1, 2, 3. Down 2, right 1, 2, 3. And I could go in the other direction too, so up to left 1, 2, 3 if I wanted to get another point that way. And I could go ahead and connect. And I'll label that as well. Okay. So again, slope-intercept form, that is something you learned last year. The reason why it's called slope-intercept form is because the slope comes first, and then the intercept, the y-intercept comes after. Y equals mx plus b. Okay, so we're just going to look at two kind of unique lines, y equals x and y equals negative x. The slope of y equals x is 1, and the slope of, y equals negative x is negative 1. And the y-intercept for both of these would be 0. It's kind of like y equals 1x plus 0. This is y equals negative 1x plus 0. So in this case, both intercepts are 0. Okay, so it's asking for some points that would lie on these lines. So the line y equals x, that means x and y are exactly the same. So I could say maybe 1, 1, 4, 4, negative 3, negative 3. The y and the x are exactly the same. So I can go ahead and plot that. 0, 0, 1, 1, 2, 2, 3, 3, and the other way too. Negative 1, negative 1, negative 2, negative 2, and so on. Okay. All right, so that is y equals x. Y equals negative x, that means that one of the values, either the x or the y, is positive, and the other, so if the x is positive, the y is negative. If the x is negative, the y is positive. Y equals negative x. One is positive, one is negative. So maybe 2, negative 2, or negative 6, positive 6, or 4, comma, negative 4. One is positive, one is negative. So those are going to go this way. And we could connect going like that. and that is y equals negative x. Okay, most of the time the equation is not in y equals mx plus b form, so we have to do a little bit of manipulation, a little bit of algebra to get it into y equals mx plus b form. So in this exercise, it's asking us to rearrange the equations in y equals mx plus b form, and then identify the slope and the y-intercept. So the first one's not too bad. We just need to subtract the 2x. And we have y equals negative 2x plus 7. Now that it's in this form, we could see that the slope is negative 2 and the y-intercept is 7. So our slope is negative 2 and the y-intercept is 7. In the next one, we have to do a little bit more. So it looks like we have to subtract 2x first. So I'm trying to isolate just y here. We're left with 3y equals negative 2x plus 12. So I want it to be just y. That means the next thing I could do is divide by 3 or multiply by a third, either or. That would go away, and we're left with y equals negative 2/3 x plus 4. When it's in this form, I could see that the slope is negative 2/3 and the y-intercept is 4. Okay, and the last one. Again, it's kind of very similar to b. Let's subtract the 4x first. So we're left with negative 6y. Don't forget there's a negative there. Equals negative 4x plus 7. Then to get the y by itself, I'm going to divide both sides by negative 6. And we'll see what we could reduce. So this reduces to just y. Negative 4 over negative 6 is a positive 2/3. And 7 divided by negative 6, I'm just going to do minus 7/6. Can't really do anything else there. So at this point, I can see that the slope is 2/3. And the y-intercept is negative 7/6. Okay. All right. So some other things that you learned last year. You learned the slope formula. So the slope formula is the rate of change in a line. And we figure out the rate of change by doing y2 minus y1 over x2 minus x1. Your teacher may have done this symbol, delta y over delta x. That just means change. So the little triangle means change in the y over change in x. And we might need to use the slope formula if we want to write an equation of a line. So in this example, it says plot the points and find the slope. It's actually not asking us to write an equation. So just taking a look here, 5, 7, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7. And negative 6, negative 3, 1, 2, 3, 4, 5, 6, 1, 2, 3, negative 3. So here is our, here are our 2 points. Okay, it says find the slope. It's going to be y2 minus y1 over x2 minus x1. Now, it doesn't matter which point you make x1, y1. You just want to be consistent. So I could say this is x1, this is y1. Maybe this would be x2 and y2. And you could reverse them. You can make 5, 7, x2, y2. It really doesn't matter. So now let's go ahead and find the slope. So I'm going to do negative 3 minus 7 divided by negative 6 minus 5. So let's see what we get. Negative 10 over negative 11, which reduces to 10/11. So that is our slope. If we counted, we would get 10/11 as well. So I'll count real quick. So going from B to A, up 10 over 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we could see it does check out. So if you didn't want to use the slope formula, you didn't have to. You could really have just counted. So the reason why the slope formula is important is because in example 2, we want to write an equation of a line that passes through those 2 points, 5, 2, and 7, -6. Now, whenever we write an equation of a line, if we're writing it into y equals mx plus b, we need 2 things. We need a slope and a y-intercept. And in order to get a slope and a y-intercept, we really technically only need 2 things. We need one point we need a point and a slope. So we need a point and a slope. If we have a point and a slope, then we're good to go. We could write an equation of a line. So we have a point. We have actually 2 points, so that's check. Now we need to find the slope. So again, I'll use my slope formula. And I'll go ahead and substitute in. So y2 minus y1 divided by x2 minus x1. -6 minus 2 divided by 7 minus 5. So simplifying the numerator, that's -8. The denominator is 2. So that's going to simplify to -4. So we have 2 things now. We have a point, we have a slope. So now we can go ahead and write an equation in y equals mx plus b. So y equals mx plus b. We need to pick any point. It doesn't matter which one. I'm going to pick this. So 5, 2 is the point I'm going to use, and then I will use -4 as the slope. And I'm just going to make some substitutions. I'm going to make 5x, I'm going to make 2y, and I'm going to make -4 as m. So I'll substitute in to solve for b. So let's substitute in. I'm going to put 2 in for y, -4 in for m, 5 in for x, and plus b. I don't know what b is. That's what we're trying to solve for. Okay, so let's see. We have 2 equals -20 plus b. Add 20 to both sides. And we get b is equal to 22. Okay, so we have our slope. We have our y-intercept. The last thing we have to do is just really string it together. It's going to be y equals -4x plus 22. And that is our equation of a line in slope-intercept form. So just to review what we did. We found the slope from those 2 points. Then we picked either of these points. It really didn't matter which one we picked. And we substituted into y equals mx plus b. We put 5 in for x, 2 in for y, and then the slope in for m to solve for b. And then we just kind of strung everything together to write the equation of the line. Example 3 is actually even easier because, well, let's see why. We want to write an equation of a line. So if we want to write an equation of a line, that's y equals mx plus b. And in order to write an equation of a line, we need 2 things. We need a point and we need a slope. And in this case, they give us a point, check, and they actually give us the slope, check. So we don't have to find the slope here. It's just a matter of substituting in. I'm going to put -4 in for y, 2/5 in for m, the slope, 5 in for x, and I'm going to let b be the variable. That's what I'm solving for. So -4 equals 2/5 times 5. You can use your calculator for it, or if you know these cross out, we're left with 2 plus b. Subtract 2. We get -6 equals b. Okay, last thing is just string it all together. We'll write it in y equals mx plus b. Here's our slope. Here's our y-intercept. So our answer is y equals 2/5 x minus 6. Okay, so that's kind of everything that you learned. Well, not everything you learned last year, but equations of lines that you learned last year. Slope, y-intercept, y equals mx plus b. A new form of a line, this is now going to be brand new, is what we call point slope form. It's actually, I actually think it's easier, and if you could write something in point slope form, definitely write it in point slope form, because I feel like there's not as much work involved. It's just going to seem a little different because you're not used to it. So we just focused on y equals mx plus b. That's slope intercept, because it shows you the slope, it shows you the intercept. There's a new form called point slope, and what point slope is going to show you is it's going to show you a point on the line and the slope of the line. So that's why it's called point slope form. So the point that it shows you is x1 and y1, and the slope is right here, m. So again, it's going to seem a little weird at first, a little strange because you've never seen it before. It's actually, I think, easier and a little bit more useful in geometry. So here's how we use it. So in this exercise, it's just asking us, hey, we're given a point, we're given a slope, write it in point slope form. So I'll write my point slope form up here. It's y minus y1 equals m x minus x1. And now we're just going to make substitutions. This is x1, this is y1, and we'll just substitute it in. So our equation in point slope form is y minus the y, so y minus 7 equals slope, so that's 4, x minus x1, so x minus 5. And that's it. You leave it like that. You don't have to do anything else. That's your equation of a line. If you were to distribute it out and get it to be y by itself, well then at that point you're actually putting it into slope-intercept form. You're putting it into y equals mx plus b, but you don't have to do that. So that's why I feel like it's a lot less work. That's it. You're done. So let's look at another one. Okay. So it's y minus y equals slope x minus x. And you don't have to show this step. A lot of you would probably just know to make it x plus 3. And that's it. Again, you're done. You don't have to do anything else. So let's look at one last one. Okay. Y minus y1 equals m x minus x1. So that's our point slope form. So it's going to be y minus a negative 5, so that's y plus 5 equals 4/5 x minus a negative 2, so that's x plus 2. And again, we are done. Leave it like that. Okay, so last question here. Okay, so we want to explore a line whose slope is 2/3 and passes through the point 4, 5. So on the grid here, we already have the point 4, 5. It's just asking us to graph it. So our slope is 2/3. That means we can go up 2 over 3, up 2 over 3. Let me backtrack down to left 1, 2, 3. Okay, and we could go ahead and connect. All right, so the first part is done. It says write the equation in point slope form. So that's the new one. That's what I think is the easier of the two. Y minus y1 equals m x minus x1. Okay, let me make my substitutions. My point is 4, 5, and my slope is 2/3. Y minus 5 equals 2/3 x minus 4. And we're done. Okay, C says write it in slope-intercept form. So if we're writing it to slope-intercept form, y equals mx plus b, Well, we could do one of two things. We could actually, if we wanted to, we could distribute this and move the 5 over, or we could just substitute into y equals mx plus b. I'm going to substitute into y equals mx plus b. So the y is, we're using the 0.5. We have a slope of 2/3. We have an x value of 4, m plus b. Okay, so we have to solve for b here. 5 equals 8/3 plus b. Now I'm going to go ahead and subtract 8/3 from both sides. So we get 5 minus 8/3. And we can make it a fraction. So that's going to be 7/3 equals b. Putting it all together, y equals, the slope was 2/3. So 2/3 x plus 7/3. Let's see if this makes sense. The y-intercept is 7/3, which is approximately 2.3 repeating, which is 2.3 repeating. So if I take a look, 2 and a little bit, yeah, I could see it's at, the y-intercept is pretty close to 2.3 repeating. So it looks like that makes sense. So two forms we looked at. One you're very familiar with, slope-intercept. The other one is brand new to you. Whenever they ask you to write an equation of a line, it doesn't matter which form you write it in, but I think in this course, you should get comfortable with this way. It's just easier. It requires less work, less chance to make an error, and that's kind of what I'm going to be doing moving forward. All right. So hopefully this, I know that, again, this wasn't ideal to have the first lesson this way, but it is what it is. So if you could try your homework, try your best with it, and submit on Google Classroom. If you have any issues, please email me and I will respond. All right. See ya. Bye.